Today, with our Learning the Basics of Unity series, we are going to look into the moving of objects, like a player, as well as how to implement the different ways that Unity can make that happen. So with that, let's get into it. So today we are going to look at many of the different ways Unity gives us to move a game object, from manipulating its position to using physics to move it around. But before we get into that, let's quickly explain how Unity does work. The engine itself runs in a constant loop, where at certain points in that loop, it is sending out what we call events. Now, two of these events are what we can use to move an object around on the screen. The first event is called the update event, where this is run so many times per second, depending on hardware, that can be run from 30 frames to 240 frames per second. The other event is called the fixed update event. And this is where we do any physics calculations that need to be done before the next physics step occurs. Physics steps are set at 0.02 seconds per step, which gives us 50 frames per second for the physics engine. This can be changed, but not something that we're going to talk about today. Okay, so with that out of the way, let's look at moving our first cube. What I'm going to do is I'm going to look at the very first option that people may think before they actually know how it works. And by selecting the first cube, I'm going to quickly have a look at the position of that cube. And most people would probably assume that by adding, like say for instance, I want to move this cube up the screen. Now I know that -3 is in that position there, but if I make it -2, then it's going to go here, -1, 0, 1, 2, etc. So that means I'm going to be adding to the Y. Now, most people would probably assume that that's what you need to do, but unfortunately, it may not be what they want for their game. So let's have a look at what that might do. So let's run the game. We've got a script here and we've got a speed of 1. We've deliberately did this for this cube. So if I hit the jump, we can see that it's jumped from here, automatically gone up 1. So it's added on the Y and it's gone to -2 instead of -3. So basically what that means is that it's not going smoothly, whereas the others may, another approach would do so. So let's look at the code for that, and then we'll discuss the other options. So the first thing we do is we get the game object's current position and we cache it into a vector3. We then get our speed, which happens to be 1 at this point, and add it to the Y for every frame. And then we store that back into the game object's position. And that, right, when that is run every frame, that means that the cube will then jump 1 unit every frame. Okay, so how do we then take that and make it move smoothly? All right, so let's look at the second cube, and I'm going to drop a script on here. And as you can see, I've got a speed of 10. Now, that speed of 10 is 10 meters per second. When, if we go back to the way Unity works, on decent computers or mid-range computers to top-range computers, everything tends to be at a 60 frames per second. So if we work on say for instance, in 1 second, if we go on 60, then we're going to look at dividing how many frames it takes to basically produce that speed. So to do that, we'll look at the code. I'll run this first, and then we'll look at some code. Okay, so when Unity's ready, If I then press play, we'll see the blue object move up 1, and then you'll see the green one smoothly go up the screen. And that is how we do it 10 meters per second. So you can actually count in Unity, basically every one of these squares, when you zoom out, it's probably it's going to be hard to see if I can get it in. Yeah, so if I get it in, you can see that Unity is based off these squares, and it's usually divided into units, which is each one of these squares will be 1 meter. So for every second or every 60 frames, then Unity is going to be 10 of these squares up the screen. Okay, so let me bring that back out. And we'll now show the code. So every update, what we will do is we'll grab the game object's current position and store that in vector 3. We'll then get the speed and multiply that by how long the frame took to run and store that in the y-axis of that position. And then we'll store it back into the game object's position. Another way that we can move the object is by using physics and velocity. So let's look at this red cube. And I've got a script here, and I'm going to, actually before I do that, I'm going to add a rigid body, and I'm going to remove the gravity off that. But I'm going to move a script onto there. And again, I'm going to add, have a speed of 10. Okay. So if we run that, we should see that the red object should move at the same speed as the green object, which is 10 meters per second. And if we then wait for Unity and hit the spacebar or the jump, we can see that both cubes are moving at a speed of 10, which is, as I said, 10 meters per second. So let's look at the code. So every update, we're changing the velocity or setting the velocity, which is, in this case, speed of 10, which is 10 meters per second. Now, we are doing that in update, and there is a very good reason for it. Now, you need to understand that with fixed update is for calculation. If you're going to set a velocity, then you set the velocity, you can set the velocity in both, but if you do it in update, then it's going to set that, and then the next time the physics step occurs, it will then run that in that scenario. However, if you were to do this in a fixed update and you happen to hit the jump button, you are not going to see the player move until the next physics step. So there could be a slight pause before the player moves. So if you do experience that, just try going back to setting the velocity in the update. All right, so now let's look at the last way to move a game object, and that is by applying force to the game object. So we've selected the yellow cube, and what we're going to do is we're going to again add a rigid body, and we're going to remove the gravity off that. And we're going to apply this script. Now you'll see, actually what I want to do is I need to explain something here. When you apply a force, the force is done by newtons. It's newtons. Basically what that means is that the movement is 10 meters per second or 10 meters per second squared. So the object will move a lot slower if we leave it at 10. So if I play that and hit the jump, you can see that the other two took off and the one object with the force is going slowly. So let me explain how that works. When you apply a force of 10, that is 10 meters per second squared. So if you want to get it to move at 10 meters per second like the other two, you need to know how often your physics is running. Now, we haven't changed anything here, so we know for a fact that the physics step is at 0.02 by default. Now, that equates to 50 frames per second. So if we were to then multiply this value by 50 to give us 10 meters per second, it will then give us 500. So that is basically saying to us over the 50 frames, we're going to move 10 meters per second. It's a little complicated, but that's how newtons work, or newtons work. So to prove that, let's now hit play, wait for Unity, and then jump. And as you can see, they're all taken off at the same time and moving at the same rate. So if we look at this code, we can see that we're doing this in an update. Now, the first thing we do is we're doing getting the button down, just making sure that we're actually hitting jump, and we're setting a variable. So it's either going to be true or false. So we then check to see if that is true, and if it's true, we then apply a force of transform up multiplied by the speed. And that is pretty much it. Now, you'll notice that we're doing that in update. Now, I'm going to be very clear here that when you apply something as a one-off, like as far as a force is concerned, then it is very safe to do it in update. If you are going to constantly apply a force to an object, you don't want to be doing that in update. You want to do that in fixed update. But as far as applying a once-off force, it is quite safe to do it in an update. And that is all 4 ways of moving a game object. Now, what works for one person may work differently for another person. And the method that you use is all going to be dependent on the type of game that you are going to be creating. So what I've shown here, it applies to 2D as well as 3D, even though these were 3D objects. You could have done the same thing for 2D. So again, it just really depends on the style of game that you want. So if you're not going to be reliant on a physics-based game, then you could use the position movement that way, and it's just going to be the same as if it was using a velocity or not. Just remember that if you do use physics, there's a little bit more overhead on using physics over just using a position-based. So again, it just depends on the type of game that you're going to be creating. So if you've got any comments, drop them below. Well, we've come to the end of another video, and I do thank you for watching. If you did enjoy the video and would like to help support the channel grow, then please do subscribe. And to get notified of new content being added, make sure to press that bell.